Hello everyone, welcome back to the A+ Tutor. Today we're going to go over how to solve similar polygons. First, let's define what similar figures are. Similar figures are polygons that have the same shape but different sizes. We can determine that two polygons are similar when two things are true. One, the corresponding angles are congruent, and two, the lengths of the corresponding sides are proportional, which is called the scale factor. Let's take an example and see what this means when we're comparing two polygons. So with these two triangles, they look like they could be similar, but we want to be able to confirm and prove that they are. So the first thing we want to check are the corresponding angles and confirm that they are congruent. Congruent means they are the same side, and corresponding angles means we're matching up the angles for our two figures. So angle A corresponds with angle D, angle B corresponds with angle E, and angle C corresponds with angle F. We want to make sure that we're picking the ones that are the same in each figure. And we see that angle A is 40 degrees, and this is congruent with angle D, which is also 40 degrees. Angle B and angle E correspond and are both 90 degrees, so they are congruent. And then angle C and angle F correspond and are congruent, and they are both 50 degrees. So we know that when we're checking our angles, these are all congruent. So we're halfway to confirming that these are similar triangles. The second step is to check the lengths of the corresponding sides and confirm that they are proportional. When we do this, we're basically going to set up a couple of fractions to see if they are equal to each other. So we're going to do AB, which corresponds with DE, is that equal to BC over EF, which are corresponding sides. We want to make sure that we're using the same triangle in our numerator and then the same triangle in our denominator. So in our numerator, we have our smaller triangle. In our denominator, we have our bigger triangle. So side AB is 15, DE is 24, side BC is 20, side EF is 32. Now we'll simplify. 15 and 24 have 3 in common, so if we divide both by 3, we get 5 and we get 8. 20 and 32 have 4 in common, so if we divide both by 4, we get 5 and 8. So we get 5 over 8 equals 5 over 8, which is true, and that means these two triangles are similar, and our scale factor is 5 to 8. So basically, our smaller triangle is 5/8 smaller than our bigger triangle. If you take any of our sides on our bigger triangle, multiply that by 5/8, you'll get the length of our smaller triangle. Let's look at a couple examples of comparing polygons to see if they are similar. Starting us off, we have these two rectangles, rectangle ABCD and rectangle EFGH. Our first step is to compare our angles, so let's see if our corresponding angles are congruent. Angle A corresponds with E, B corresponds with F, C corresponds with G, and D corresponds with H. All of these angles are 90 degrees in both figures, so we know that all the angles are congruent. Now, let's see if the lengths of our corresponding sides are proportional. So side AD corresponds with EH, AB corresponds with EF, and then on the flip side, BC corresponds with FG, and CD corresponds with GH. So let's compare AB and BC, and then EF and FG. Those are our corresponding sides. Let's see if they are proportional. We'll do AB over EF. Is that equal to BC over FG? AB is 14 and EF is 36, so that's our first fraction. BC is 10 and FG is 24, that's our second fraction. 14 and 36 have a common factor of 2, so when we factor out a 2, we're left with 7 over 18. 10 and 24 also have a common factor of 2. So when we factor out a 2, we're left with 5 over 12. 7 over 18 does not equal 5 over 12. Therefore, these two figures, these two polygons, are not similar. Next, we have these two triangles, and we want to state whether they're similar. So let's start by identifying our corresponding angles. So this time, we're not seeing these two figures next to each other in the exact same orientation. We've got one with the hypotenuse on the bottom of the triangle and the other with the hypotenuse on the top. So you want to just kind of make sure that you are picking the right angles that are corresponding based on the orientation. So you have to kind of imagine a bit. If I flipped and rotated the triangle on the right, if I flipped it over a horizontal line and then flipped it over the vertical line and basically took a mirror image of this, that's going to be the same orientation, which means, or if we rotate this 180 degrees, that means that angle P corresponds with angle M, angle R corresponds with angle O, and then angle Q corresponds with angle N. So those are going to be our corresponding angles, and then we can also determine our corresponding sides from there. The other thing with this is that we see that we're missing an angle in each of our triangles. On our left triangle, angle O does not show what measurement it is. On our right triangle, angle P doesn't have the measurement, but that's easy to solve. We can definitely really simply find these angles. So angle O, if we remember, the interior sum of our angles for a triangle is 180 degrees. So we know that 180 is going to be equal to our 43 degrees plus our 90 degrees plus angle O. So if we subtract 43 and subtract 90 from both sides, we get that 47 is equal to angle O. So now we know that this is 47 degrees. Let's do the same thing with our angle P so that now we can compare and we can solve and see if these are similar figures. So 180 is going to be equal to 47 plus 90 plus angle P. Now we want to subtract 47 and 90 from both sides. So that leaves us with 43 is equal to angle P. Now we can compare and see if they're congruent. So as we pointed out before, angle M corresponds with angle P, and they're both equal to 43 degrees, so those are congruent. Angle N and angle Q are corresponding and both equal to 90 degrees. And angle O and angle R are corresponding and both equal to 47 degrees. So we know that all of our angles are congruent. Now let's look at our sides and see if our corresponding sides are proportional. So side MN corresponds with PQ and side NO corresponds with QR. The way that we can determine this is we can use our angles as a guide. M is our 43 degree angle, and then N is 90 degrees. And in our other triangle, P is 43 degrees and Q is 90. So that's how we know MN corresponds with PQ. And then O is our 47 degree angle, and R is also our 47 degree angle. So NO will correspond with QR. So we'll set up our proportion. MN over the corresponding side, PQ, is that equal to NO, so same triangle, over QR. So that's going to give us MN is 10, PQ is 5, NO is 8, and QR is 4. On our left fraction, we can factor out a 5, and we're left with 2 over 1. On our right side, we can factor out a 4, and we're left with 2 over 1. So 2 over 1 is equal to 2 over 1, which means these two figures are similar. And our scale factor of our first figure to our second figure is 1 to 2, because one side in our first figure takes double the side in our second figure. Once you know two polygons are similar, you can use the scale factor to find the missing sides. So to find, as we saw, to find our scale factor between two polygons, we're using the proportion of our sides. When we're missing a side on a polygon, you have two ways of finding that missing side. You can either use the scale factor and multiply that to the corresponding side to find the value, or you can set up a proportion and cross multiply to solve for your missing side. Let's look at both of those here. So let's find our scale factor. We've been told that these two triangles are similar. If we're already told, or if we know that these two triangles are similar, then we can find our scale factor. So in this case, let's assume that these two triangles are similar, and let's find our scale factor. So our scale factor is going to be our proportion of our corresponding sides. Our 35 length side corresponds to 14. We're just going to kind of look at our triangle and make that assumption because we know they're similar in this case. Let's find our scale factor, and let's find it in terms of our smaller triangle to our big triangle. So we'll take our corresponding sides. 14 corresponds with 35. So we'll set up that proportion, that fraction, 14 over 35. Simplifying that, 14 and 35 have a common factor of 7. So if we take 7 out, we get 2 at 14. And if we take 7 out of 35, we get 5. So our scale factor is 2 to 5, small to our big. So now we know that our x is 2/5 smaller than the corresponding side. So x is going to be equal to that corresponding side, 25, times the scale factor, which is 2 over 5. So that gives us 50 over 5, and x is equal to 10. So that means our missing side is 10. So that's how we use the scale factor. It's really important to know how the scale factor was determined. If it's the smaller to the bigger, bigger to smaller, that way you know how to use it. If we had done big to small, our scale factor would have been 5 over 2, and we would have had to divide by 5 over 2. One trick you can use is that when you have a fractional scale factor, that's small to big, for every side on our big triangle, 2/5 of that is our smaller triangle. And if it's the reverse, 5 over 2, because it's more than 1, for every side on our smaller triangle, 5/2 of that is going to equal the length of our bigger triangle. And we can verify this using our proportions to do the same thing. We'll set up proportions with corresponding sides, cross multiply, and we would be able to solve for x. So for our proportions, 40 corresponds with 16, and 25 corresponds with our x. So let's set up that proportion. 40 over 16 should be equal to 25 over x. When we cross multiply, we're going to multiply 40 and x and 16 and 25. So 40x is equal to 16 times 25, which is 400. So 40x equals 400. We divide both sides by 40, and we get x equals 10. So again, it's the same thing that we got when we used our scale factor, and we confirm that this is 10. So when you are using similar polygons to find a missing side, either method works. You can either use a scale factor or use proportions. I'll show you a mix of both as we go through some examples, but you can always use whichever method you are more comfortable with. For the following similar figures, let's find the missing side. Starting us off, we have these two parallelograms. We are already told that they're similar, so we don't have to go through the steps of finding they're similar. We just want to find the missing side. And as I just showed you, we can do this one of two ways. We can either use the scale factor or we can set up proportions and cross multiply. I'll show you both ways. That way we can see we're always getting the same answer, and then you just pick the way that is best for you. So first, let's find our scale factor. Our scale factor from small to big, and for all of these examples, we'll always do small to big. Our scale factor from small to big, we need to set up a proportion. Let's figure out which sides are corresponding. our 6 will correspond with our 12. Those are both either the bottom or the top of our parallelogram. So those are going to be our corresponding sides. So our fraction will be 6 over 12, and then we'll simplify that. Both of our factors are divisible by 6, so we're left with 1 in our numerator and 2 in our denominator. That means our scale factor is 1 to 2. So from small to big, our smaller parallelogram is half the size of our bigger parallelogram. So that means we can say 1/2 of x is equal to its corresponding side, which is 5. So now in order to figure out what x is, we're just going to solve for x by multiplying by 2 on both sides. We get x is equal to 10. So we know that our missing side is 10. Now let's see if we get the same answer if we set up some proportions and cross multiply. So again, we want to make sure that we're following our corresponding sides. Our two fractions will be 6 over 12 is equal to 5 over x. We'll cross multiply, so 6 times x will equal 5 times 12, or 6x equals 60. If we divide both sides by 6, we get x equals 10, which is exactly what we just proved with our scale factor, so we know that we have the same answer, and our missing side is 10. Now we have these two similar triangles, and we have our missing side. So let's start by finding our scale factor. Since we're going to do small to big, we want our smaller triangle's side on top and our larger triangle side on the bottom. And we have two options to pick for corresponding sides. So we can either do 4, which corresponds with 8, or 7, which corresponds with 14. Both will give us the same scale factor. So 4 over 8. Both of these have a factor of 4, so we can simplify there. We get 1 in our numerator and 2 in our denominator, which means our scale factor is 1/2 or 1 to 2. So our x is going to be equal to half of the corresponding side because that's our smaller triangle. So x is equal to 1/2. The corresponding side is 10, which means x is equal to 5. So our missing side value is 5. Now, if we try our other way, set up some proportions, we should get the same thing. Let's set up some proportions with our corresponding sides. So 10 corresponds with x, and that's going to be equal to 14, which corresponds with 7. If we cross multiply, we get 70 equals 14x, so 10 times 7 is 70, 14 times x is 14x. Divide both sides by 14, and we get 5 on our left side and x on our right side, which is the exact same. So we know that x is 5. Again, just showing you that you can use either method, and as long as you're doing it correctly, you'll come to the same answer. Now we have this figure where we have a large triangle and a couple lengths of our sides, and then a smaller triangle within this figure. So in reality, we have two separate triangles that, again, are similar. So we have to determine how we work with these triangles in order to find the scale factor and then to find that missing side. So what we can do is we can break this apart into two triangles. We have our bigger triangle, which has a side length of 15 on the bottom. And then this entire side length is 6 plus 4, which is 10. So we have a side length of 10 and a side length of 15. And then we have a smaller triangle within that has a side length of x at the bottom, and then 6 because we're just using that portion of the triangle. So now using these two triangles, we can take our same steps. So we'll find our scale factor. Let's do small to big, just like always. So small, we have 6. Our corresponding side for the 6 will be the entire length, which is 10. We can simplify this. So 6 and 10 have a common factor of 2. In our numerator, we'll have 3. And on our denominator, we'll have 5. So that means we're left with 3/5, and our scale factor is 3 to 5. So our bigger triangle, if we take those sides and multiply by 3/5, we'll get the length of our smaller triangle. So let's do just that. X is going to be equal to our corresponding side for x is 15. So 15 times our scale factor, which means x is equal to 15 and 5 can be simplified. 15 goes into 5 3 times, and 3 times 3 is 9, so x is equal to 9. Let's confirm by doing the same with our proportions. So we can set up a couple proportions. 6 over 10, because those are our corresponding sides, will be equal to x over 15. When we cross multiply, 6 times 15 is 90. So 90 is equal to 10x. Divide both sides by 10, and we get x is equal to 9, which is the exact same that we found, and we've confirmed. So again, we have a smaller triangle within a larger triangle, so we'll break this up in order to find our x value. So our larger triangle has a hypotenuse of 12.5, and our side length is actually going to be x plus 4, because we have a portion here that is value x and then a portion that is 4. So our entire side length is x plus 4. And then for our smaller triangle, it's 3, 4, 5. So let's start by finding our scale factor so that we can work to find that missing side. So for the scale factor, our hypotenuses are corresponding sides. So we'll use those to find that scale factor. So we'll still do small to big. So 5 over 12.5. This does not just simplify really easily because, of course, we have a decimal in our fraction. So when we divide that, we get 0.4 as our scale factor. And if we convert that to a fraction, 4/10, that would be 2/5, and that would make our scale factor 2 to 5. So 2 of our larger triangle is equal to 5 of our smaller triangle. Or 1 of our larger triangle is equal to 2.5 of our smaller triangle. So when we get into cases like this where we have decimals involved, there's a few different ways that you can do it. I like to just convert it back to a fraction to find that fraction, and I feel like that's easy to work with. But you can also just use the 0.4, multiply that to your side, and get the value. So there's a number of different ways we can do this. So if we use our scale factor, which is 2 to 5, we know that from small to big. So 4 is equal to 2/5 of our bigger side, which is x plus 4. We can get rid of this fraction. Instead of distributing it, we can multiply both sides by the reciprocal. So if we multiply both sides by 5/2, we can get rid of this fraction. On the right side, we're just left with x plus 4. And on the left side, we're left with 10. So 10 is equal to x plus 4. Subtract 4 from both sides, and we get x equals 6. And our side length is actually that x plus 4, which is 10. So this entire side length is 10, and our x is equal to 6. So let's do the same thing with our proportions to see if we find the same value. So when we set up our proportions, we get 5 over 12.5 is equal to 4 over x plus 4, because we want that entire side. So we'll cross multiply. 5 times x plus 4 is equal to 12.5 times 4 is 50. Divide both sides by 5, and we get x plus 4 equals 10, which is exactly what we just proved. And then when we subtract 4 from both sides, we get x equals 6, which is exactly what we were looking for. So again, even if we're seeing we have to get the entire side length, we have to do some sort of calculation with our x or solve for something, we're still able to use the same process. We just want to make sure we're paying attention if we need the x value, if that's what we're looking for in whatever problem we're doing, or if we need the side length. So if we need the x value, x is equal to 6. If we need the side length, that's equal to 10. So you always just want to make sure that you're finding exactly what it is that you're solving for and providing the correct answer. So again, with these two polygons, we want to make sure we're finding the missing side. So we need to find the entire side, not just our x value. So let's get started. Let's start by finding our scale factor. So for our corresponding sides, we have 16 and 40. Those are the only sides that we can use because we don't know the lengths of the other two sides for the trapezoid, for our smaller trapezoid, so we have to use 16 and 40. 16 over 40 will simplify. So both of these are divisible by 8. So if we factor out an 8 in our numerator, we're left with 2. We factor out an 8 in our denominator, we're left with 5. So this is going to be 2/5, or our scale factor is 2 to 5. So that means that 2x plus 4 is equal to 2/5 of the corresponding side, which is 45. 5 and 45 have a common factor of 5, so we can cancel out our 5 in our denominator, and we're left with 9 in the numerator, which means that 2x plus 4 is equal to 18, which is what we're looking for. So we can stop here. If we wanted to find the value of x, then we can continue to simplify and solve for x, but we can stop here because we found the missing side. Let's just find our value for x. We subtract 4 from both sides. We get 2x equals 14 divided by 2, and x equals 7. So if we did need to know the value for x, it would be 7, but the missing side is 14. Let's do the same thing and find this using our proportions. So we can set up our proportions using our corresponding sides. 40 over 16 is equal to 45 over 2x plus 4. So we'll cross multiply. 40 times 2x plus 4 is equal to 16 times 45, which is 720. We'll divide both sides by 40, and we'll get 2x plus 4 is equal to 720 divided by 40 is 18, which is again exactly what we saw for the value of our side, and we can stop here. So we know that our missing side is equal to 18. And this is our last example where, again, we want to find the missing side. Let's start by using our scale factor. So for our corresponding sides, we can either use 30 and 35, those are going to be corresponding, or 42 and 49, which are also going to be corresponding. Let's use 30 and 35. So 30 over 35. We can simplify this fraction using a factor of 5. 5 goes into 30 6 times, and 5 goes into 35 7 times. So this is going to be 6 over 7, or our scale factor is 6 to 7. So now we can use that to find our missing side. Our hypotenuses are corresponding, so 6x minus 6 corresponds to 63, which means 6x minus 6 is equal to 6/7 times 63. 7 goes into 63 9 times, so 6x minus 6 equals 6 times 9, or 6x minus 6 equals 54. And that's our side length. So again, we can stop there. If we wanted to take it a step further and solve for x, then we'll just add 6 to both sides, and we'll get 6x equals 60. Divide by 6 and get x equals 10. But we found our side length, which is 54. We can do the same thing using proportions. So if we set up our proportions, 42 and 49 are corresponding. So we can say 42 over 49 equals 6x minus 6 over our corresponding side, which is 63. When we cross multiply, we get 42 times 63, which is 2,646, equals 49 times 6x minus 6. Divide both sides by 49, and we get 54 equals 6x minus 6. Again, that's exactly what we found before, and that is our side length. Thank you so much for watching. I hope you enjoyed the video, and I hope you learned something. If there are any topics you'd like for me to cover, please leave them in the comments below. If you're not subscribed to my channel, hit that subscribe button, and if you like the video, give it a like. See you next time.